So, okay, we start with problem 2. It's the same problem as we had in the previous class, but with other utility functions. Consider a simple 2x2 endowment economy with two individuals, as always, that have following preferences. Individual A, the utility function is 2 square root out of x1a plus square root out of x2a. Utility for individual B is the same as in the previous class, xb1 multiplied by xb2. Cobb-Douglas preferences, easy. Endowments. Individual A initially has 2 units of good 1 and 0 units of good 2. Individual B initially has 0 units of good 1 and 1 unit of good 2. So, our first question. Do there exist gains from trade? How we checked it in the previous class? We counted margin rates of substitution, and if they are not equal, we say that this point is not efficient, and we should check in what region we have Pareto improvements. So now let's check that what margin rates of substitution we have, and then check the direction of Pareto improvements. So marginal rate of substitution for first good by second good for individual A is marginal utility from good 1 for individual A is partial derivative by x1a is how much? 1 divided by square root out of x1a divided by partial derivative by x2a is 1 divided by 2 square root x2a. So revert 2 square root x2a divided by square root x1a. Margin rate of substitution of first good to second good for individual B is, we counted it in the previous class, x2b divided by x1b. So put the initial point into margin rates of substitution, and let's find the slopes of tangent lines to different curves in this point. So margin rate of substitution for individual A in the endowment point is how much? We have 1 unit of good, or 2 units of the first good and 0 units of the second good. Second good is here, so it will be how much? 2 square root out of 0 divided by square root out of 2, it's 0. So the slope is 0, horizontal line. And margin rate of substitution individual B in the initial point is here 0, 1. Let's see. 1 unit of the second good and 0 units of the first good. 1 divided by 0, it's infinity. So we see that slopes are not equal in this point. So make the conclusion that we have been, there exists gains from trade. But we should check, because this is corner point, you see, we have 0 consumption. We should check that Pareto improvements are in right direction. I will draw the sketch and then erase it. This for A, this for B. Initial point 2, 0, so it will be here. This is the endowment point. And what we have? The slope of tangent line to indifference curve for individual A is 0, so it's horizontal. So Difference curve will look like this. For individual B, margin rate of substitution infinity in this point, so it is vertical line. So utility indifference curve will look like this. And I put an arrow as the direction of the utility growth. So, and you see where they want to move, to the left and up. Here are Pareto improvements. And it was logical because individual A has only good 1, but he wants to have good 2 also. So he wants to sell first good and to buy second good, and vice versa is everything about individual B. And you see that exactly individual A wants to sell the first good, so to move left, and wants to buy second good, wants to move up. So move here and up. So exactly this point, down point, is not efficient for us right now. We can write this, that individual A will be seller of good 1 and buyer of good 2. Individual B will be seller of good 2 because we want to move up, and buyer of good 1. So next, what else we should find here? Second task. I will erase this. In the second point, we should check other point where consumption for individual A is 1/4. Consumption for individual B is how much? 1/3. So let's check this point. Put this point into marginal rates of substitution and see if they are equal or not. Here, how much? 2 square root out of 1/4 divided by square root out of 1, it is 1. Margin rate of substitution for individual B in his consumption point is second good divided by the first good is 3/4. We see that they are not equal. So this point, we make the conclusion, this point is not Pareto efficient, not optimal. But also we can say who wants to sell what good. Let's draw the sketch. We see for individual A, margin rate of substitution is bigger than for individual B. So the slope for individual A will be flat, steeper. So for individual A like this, individual B flat. So you see that Pareto improvements are where? To the right and down. Yes. So from this point, if we move from this point, individual A wants to buy first good and want to sell second good, and individual B vice versa. We can write that A will be buyer of good 1 and seller of good 2. And B vice versa. B wants to buy second good and wants to sell first good. Guys, please, is it clear?
Yes.
Great. In the third task, we should find excess demands for each good. But first of all, for finding excess demand, we should find the demand of each individual for each good. So, point 3, let's start from individual A. We know how to find demands from utility maximization program. So, always we write down this utility maximization program subject to budget constraint, this to x1a plus square root x2a. We should maximize by choosing x1a, x2a non-negative, subject to budget constraint. So expenses for consuming both goods multiplied by prices, P1 x1a plus P2 x2a of expenses should be less or equal to income in money terms. So we have in natural terms, individual A has only 2 units of first good. So in money terms, this will be P1 multiplied by 2. Firstly, we should prove that budget constraint holds with the quality. What we write? We can write that preferences of our individual are monotonic, so locally non-satiated. That's why we will never waste endowment, and that's why budget constraint binds for this individual. Let's write that preferences are monotonic. That means more is better. That's why budget constraint binds. Binds means holds with the quality. So, and we know that for interior solution, optimal condition is marginal rate of substitution should be equal to the price ratio. So the slope of the tangent line to indifference curve should be equal to the slope of budget constraint. Let's write down this. For interior solution, marginal rate of substitution of the first good to the second good for individual A should be equal to the price ratio. We counted marginal rate of substitution. That was 2 square root out of x2a divided by square root out of x1a should be equal to P1 divided by P2. From here, let's derive, for example, x2a. What it will be? x2a will be equal to P1 squared divided by 4P2 squared multiplied by x1a. So this is optimal proportion of consumption of 2 goods by individual A in optimum. But now we have one equation and 2 unknowns. So we should put this equation into second one, into budget constraint. Instead of x to a, we write down this proportion. P1 square, 4P2 square, x1a equal to P1 multiplied by 2. From here, let's delete something. And P1 also. So x1a multiplied by 1 plus P1 divided by 4P2 will be equal to 2. And the demand for the first good by individual A will be equal to 8P2 divided by 4P2 plus P1. This is the demand function, and excess demand function of individual A for the first good is the difference between the demand, how much he wants, and how much he has, and endowment of this good. And he has 2 units, so it will be 8P2, 4P2 plus P1 minus 2, 8P2 minus 8P2 minus 2P1 divided by 4P2 plus P1. And this is minus 2P1 divided by 4P2 plus P1. We see that excess demand is negative for each price, a non-zero price. So what that means? That means that individual A wants to sell the first good if he moves from the endowment point. So he wants to sell good one. Let's find the demand of individual A for the second good. What we should do? We should put in this optimal proportion the demand for the first good. It will be P1 square divided by 4P2 square multiplied by 8P2 divided by 4P2 plus P1. So here, 4, here 2. So this will be 2P1 square divided by P2 multiplied by 4P2 plus P1. Let's check. Let's check that we found everything right. For demand, if the price of the good goes up, the demand should go down. So this holds, everything is okay. And what we can say about excess demand of individual A for the second good? We know that this is the difference between demand and endowment, but we don't. But individual A do not have endowment of the second good, so the demand will be exactly equal to excess demand of individual A for the second good, because it is x to A minus 0. So we found everything for individual A. Let's find everything for individual B. But for individual B, we counted everything in the previous class because we had this utility function. But anyway, we should write down every time utility maximization program. So what we solve, and then we can write the answer. So for individual B, he maximizes x1b multiplied by x2b by choosing his consumption point, non-negative, subject to his budget constraint. His budget constraint is what? P1 x1b plus P2 x2b should be less or equal than his endowment in money terms. He has 0 of good 1 and 1 good 2. So this would be P2 multiplied by 1. Then, as always, we say that preferences are locally non-satiated. That's why budget constraint binds, holds with equality. And then we can say that, for example, these are Cobb-Douglas preferences, and we know the formula for demands. of Douglas preferences. So the demand for individual A for the first, or of individual B for the first good is what? Alpha divided by alpha plus beta multiplied by his endowment in money terms divided by the price of the first good. This will be, so alpha and beta are equal to 1. So this will be 1/2 multiplied by endowment in money terms P2 divided by P1. This is the demand of individual B for the first good. The demand of individual B for the second good is formula B beta divided by alpha plus beta multiplied by endowment in money terms divided by the price of the second good. And this is 1/2 multiplied by P2 divided by P2. So this is exactly 1/2. What about excess demands? Excess demand of individual B for the first good is the difference between demand and how much he has this good. He has 0. So this will be P2 divided by 2P1 as the demand. And excess demand of individual B for the second good is how much? 1/2 minus how much he has this good? 1. Так, ой, ребята, меня видите, слышите?
Да. Но только мы вас вроде хуже стали видеть.
Да? Ну, сейчас, я думаю, восстановится. У меня, короче, типа просто выключился комп, и все. Я такая, что с делами? Вот. Ну, все, прошу прощения. Вот, вроде обратно подрубился. Ой. Так, so, let's continue. So, what we have? We see that the excess demand of individual B for the first good is positive for each price, non-negative, yes? So he wants to buy the first good, and excess demand of the of individual B for the second good is negative, and we see how much exactly he wants to sell. He wants to sell 1/2 of his endowment. We can write this. So B will be a seller of good 2 and buyer of good 1. So where are our demands? X1A, X1A here, X2A here, X1B, this one, X2B, 1/2. Our question also for this point is, can there exist competitive equilibrium with some price equal to 0? Let's check. What if the price for the first good will be equal to 0? Can such price be in equilibrium? What you can say?
No,
Why?
because if the price 1 is equal to 0, our x b1 is also equal to 0, but it should be equal 1/2 or something.
X1b will be equal to infinity. B1 is, you see?
Okay.
Yes, but yeah, you're absolutely right that we should consider X1b. So with the price for good 1 equals to 0, the demand of individual B for the second good will be P2 divided by 2 multiplied by 0, and this is plus infinity. But we don't have such a big amount of the first good in our economy. Yes, so this is not feasible for us. Not feasible. That's why P1 equal to 0 cannot be equilibrium price. So, same. If the price for the second good is equal to 0, what you can tell me? Can it be in equilibrium? What demand we should consider?
We can consider x2a, and
you see
it
here
also equal a plus infinity.
Exactly. So this will be for such price, the demand of individual A for the second good will be equal to also plus infinity, and this is also not feasible. So there not exist competitive equilibrium with price of good 2 equals to 0. So we prove this. Next. In the fourth point, we should find the competitive equilibrium. But you know how to find this. Let's do it. In answer, we should write down equilibrium price ratio, you remember, and equilibrium point. Equilibrium point, equilibrium allocation. So first of all, we should find equilibrium price ratio, price vector. Markets, each market should be clear. Yes, market's clear. What that means? Demand should be equal to supply. Let's use this. For example, consider, let's consider market for good 2. In this market, the aggregate demand should be equal to aggregate supply. Aggregate demand is what? The demand of individual A for the second good plus the demand of individual B for the second good. This is aggregate demand. And what is aggregate supply of this good? This is exactly how much of this good we have in economy. So this is the sum of endowments of this good. And this is how much? 0 plus 1. Yes? This is supply. Aggregate supply. So let's sum up our demands. X to A square. 2P1 square divided by P2 4P2 plus P1 plus the demand of individual B for second good is it is 1/2 should be equal to 1. So let's find let's solve this. What it will be 2P1 square and here will be minus 1/2, yes? Okay, divided by 4P2 square plus P1 P2 minus 1/2 should be equal to 0 or equal to 1/2. Right like this. So 4P1 square will be equal to 4P2 square plus P1 multiplied by P2. And 4P1 square minus P1 P2 minus 4P2 square will be equal to 0. So let us divide by P2 square, for example, to find a price ratio. This will be 4P1 divided by P2 square minus P1 divided by P2 minus 4 equal to 0. You see that this is quadratic equation, yes? So D will be equal to what? B square 1 plus 4 multiplied by 4 multiplied by 4. Yes, this 65. And let's find price ratio. The first root, P1 divided by P2 will be equal to what? Minus B, this is 1, plus square root out of 65 divided by 2A. 2A, this is 8. And the second root is 1 minus square root out of 65 divided by 8. And it is negative, so we don't use it. Equilibrium price ratio will be equal to 1 plus square root out of 65 divided by 8. And now we should find the equilibrium allocation. Put this price ratio into all our demands. And let's find. X1A will be equal to how much? I forgot the demand. Let's see. X1A. This is 8P2 divided by 4P2 plus P1. Let's divide everything by 2, by P2. This will be 8, 4 plus P1 divided by P2. And this is 8 divided by 4 plus this equilibrium price ratio, 1 plus square root out of 65 divided by 8. And this is how much? 48 divided by 33 plus square root out of 65. And this is approximately, I counted, but I forgot, 1.56, approximately. No, 56. Then, so X1B will be endowment, aggregate endowment minus the demand of individual A. We have 2 units of first good in our economy, so it will be 2 minus 64 divided by 33 plus square root out of 65. And this is 2 square roots out of 65 plus 2 divided by 33 plus square root out of 65. This is approximately 2 minus 1.56. This is 0.44 approximately. What about the demand for the second good? We know it. The demand of individual B for the second good is exactly 1/2. We counted it. Yes, it does not depend on price, and that's why the equilibrium demand of individual A for the second good should be also equal to 1/2, because we have endowment of this good equals to 1 in the economy. 1 minus 1/2, it is 1/2. So let's write down the answer. The competitive equilibrium is in our economy right now. Price ratio, equilibrium price ratio equals to 1 plus square root out of 65 divided by 8. And equilibrium allocation is individual A consumes the first good 64 divided by 33 plus square root out of 65. Second good 1/2. Individual B consumes x1b 2 square root out of 65 plus 1 divided by 33 plus square root out of 65 and 1/2 of the second good. So this is the answer for finding the competitive equilibrium. We have the question in this point: is this competitive equilibrium unique? Yes, it is unique by construction, because we found only one competitive equilibrium, and that's all. And also, we eliminated the possibility for having the competitive equilibrium with 0 prices. See previous point. Let's write down it. By construction, competitive equilibrium is unique in this economy. And also, we eliminated the possibility how to in this economy with price ratio positive. Also, point 3. Excluded all possible equilibria with 0 prices, with P1 equal to 0 or P2 equal to 0. We proved that it is not possible. Let's put this competitive equilibrium in the edge box. Endowment point 0, 2, and competitive equilibrium point is approximately 1.56. It's here 2, and here 1.56. It's somewhere here. So this will be 1.56. At the same time, the consumption of individual B of the first good is 0.44. And they consume, if here 1, they consume half each of the second good. So this equilibrium, allocation, and competitive equilibrium. But also what we should draw. We should draw a budget constraint with optimal slope, with optimal price vector. Let's do it. We know that budget constraint, we know that our endowment point always belongs to our budget constraint because it's our natural income in natural terms. So our budget constraint should move through 2 points, through endowment point and competitive equilibrium point. And this will be equilibrium price ratio, the slope of the budget constraint. We counted it. Equilibrium price ratio. So now we draw the competitive equilibrium. Here star. Here I also put P1 divided by P2 star. Yes, in equilibrium. Also, you can draw, but it is not obligatory. You can draw indifference curves for individual A that is tangent to budget constraint, and for individual B, which is also tangent to our budget constraint at the same time as indifference curve for individual A. So that's all for point 4 and point 5 of this task. We should answer, do the first fundamental welfare theorem and second fundamental welfare theorem hold for this economy. What is that? So what you can say about first fundamental welfare theorem? It holds or no, or not? Guys?
Yes.
Sure, because what our first fundamental welfare theorem tells us.
Markets are complete.
Markets complete and
individuals non-associated preferences.
Yes, individuals have locally non-stated preferences. Let's write down it. First fundamental welfare theorem holds as both individuals have locally non-stated preferences. Why? Because they have monotonic preferences. More is better. You should explain it. And markets are complete. What that means? We have 2 goods and exactly 2 markets. On both markets, we have perfect competition, so price taking assumptions holds. And what else? Demand is equal to supply on each market, for example. Demand equal to supply for each market. So you should explain why market's complete. You should explain why both individuals have local and associated preference. Here are explanations, small explanations. And what about the second fundamental welfare theorem? What we should add to all this? One more.
Something about convexity. No?
Mm-hmm. Yes, exactly. Second fundamental welfare theorem holds as both individuals. Let's not hold, but also holds, because we begin our explanation from here. Also holds as both individuals have convex preferences. How we can prove it? In general, strictly, we should find the matrix of second derivatives and Hessian, and say that quadratic form is non-positive, yes? But we will not do it. And let's say, for example, sketch. Let's draw the sketch of indifference curves for both individuals. Here good 1, here good 2, and indifference curves looks like this. And this that means convexity. If indifference curve looks like this, we work with convex preferences. Okay, and that's all. Some small explanation. So let's see. Mm-hmm. Also, we can write what that means. What means that fundamental welfare theorems hold? Okay, let's see. So from first fundamental welfare theorem, all competitive equilibria are Pareto efficient. From second fundamental welfare theorem, we can decentralize any Pareto efficient allocation as competitive equilibrium with transfers. So this is how we can answer the fifth point. With the second problem from this class, we finished it. Guys, please questions. I begin to raise, and we will continue our class with the first problem.
Our preferences is not convex when the first good is bad for us and the second is good?
No, not exactly. Convexity means x1, x2. So the preferences are convex if our indifference curves looks like this, and we move here. If our preferences, this is convex, yes, and concave. For example, like this, indifference curves looks, and concave, and the direction of utility grows here. This is concave. And if we have like this indifference curve, these preferences are not convex and not concave. Okay?
Okay.
Not convex, not concave. If we have linear preferences, what you can say, what you can tell? Linear preferences, they are at the same time convex and concave. So for linear preference, we will say that these preferences are convex, and all theorems holds. Is it clear?
Yeah.
Or if indifference curve looks like this, also convex, because linear functions, they are at the same time convex and concave. So also for such preferences, everything will hold. Oh. Oh. Next, problem 1. We should answer 2 simple questions. Let's read. First question. Competitive markets always function perfectly and never fail. Is it true?
I think no.
Why? It is false. How we can, what we can say?
Maybe just give example from the history.
Yes, if we say that the statement is false, so we need only at least one counterexample. Yes. So in what situations competitive markets do not function perfectly? When they fail. If there is, for example, if there is not perfect competition, for example, monopoly, monopolistic competition, oligopoly, or something like this, if there is not perfect competition, so if price taking assumptions does not hold, so here there will be market failure. We will have deadweight losses, yes? And also the other example when markets will fail is when we have more goods than markets. It's an example of externality. Yes, you can write some or about price taking assumptions or about more goods than markets or everything like this. That's right. From first fundamental welfare theorem. If markets are incomplete, what that means? Example. For example, we have externalities. And that's why more goods than markets. And or price taking assumptions do not hold. This is when, for example, when we have monopoly or oligopoly, something like this. What that means? In this situation, competitive equilibrium is no longer Pareto efficient. Competitive equilibrium is no longer Pareto efficient. So we have deadweight losses. That's why markets fail. And if we have market failures, if we have deadweight losses, our government should help. Our government should intervene and help. That's why state must intervene to restore efficiency. This is the answer for the first question. Second question. Let's read. 2x2 pure exchange economy with non-associated preferences. 2x2 preferences locally non-associated. What else? The value of the aggregate excess demand must be equal to 0 for any price level. Aggregate excess demand, what that means? That means the sum of excess demands should be equal to 0 for any price level. Is it true or false?
Yes, it's true.
It is exactly true, and this how we can prove using Walras law. Yes, let us derive the Walras law. This is true. The statement is true, and let's prove it. I begin to erase. Let's write down budget constraints for both individuals. For individual A, budget constraint is what? P1 x1a plus P2 x2a. These are all expenses, should be less or equal than his endowment in money terms. Individual B. First, what we can say, as we have local and stated preferences, budget constraints, both binds. And then we have here demands and here endowments. If we move everything from the right side to the left side, we will find excess demands. Yes, let's do it. P1 x1a minus e1a plus P2 x2a minus e2a should be equal to 0. It is for A for B. P1 x1b minus e1b plus P2 x2b minus e2b should be equal to 0. You see, these differences are exactly excess demands. And we should find aggregate excess demands, so we should sum up all these excess demands. So let's sum up these two budget constraints. What we will find? P1 multiplied by the sum of excess demand of individual A for the first good and excess demand for individual B for the first good plus P2 sum of excess demand for individual A of the first good plus excess demand for individual second good here. For the second good. And all this should be equal to 0. This is exactly the Walras law. What that means? That Walras law tells us that if we have one market, or for two markets, if we have one market in equilibrium, what that means? Excess demand, the sum of excess demands on this market equals to 0. So if these brackets are equal to 0, that means that the sum of excess demands for the second market should be automatically equal to 0 also for this sum equal to 0. This should hold also. And this sum of aggregate excess demands equal to 0. This what our statement exactly tells us. So we proved. Let's draw it. Or not draw, let's write down it. Which is exactly what the statement says. So, end of the proof. And you see that that when the statement is false, it is easier to prove, it is easier to find counterexample than to prove in general that the statement is true. But you should know how to prove true statements and false statements at the same time. From my side, that's all what I wanted to tell you today. If you don't have questions, so thank you. See you next Tuesday. If you have questions, I begin to erase, and please, guys, ask.
Thank you. Bye-bye.
Bye-bye. Okay. See you next Tuesday. Bye-bye.